So we are working on solving linear equations. Last time we learned the vocabulary and the properties that went with this, and we did some very simple examples. This time we're going to be working on some more complicated examples. So we are going to jump straight to example 3, right where we left off last time. Following our checklist, again, the first thing that we want to do is to simplify each side of the equation individually. Nothing I can do on the left and nothing I can do on the right because I do not have any like terms. So what I need to do then is I need to start performing opposite operations to isolate my variable. Again, my goal here is to get this x completely isolated by itself. Now, when we were looking through these steps last time, I told you that you need to use the addition and subtraction property before you multiply and divide, and let me prove to you why here. If I wanted to isolate my x by first getting rid of that 2, what I would have to do is I would have to divide by 2, which seems pretty easy here. But the properties of equality say that you have to divide the whole side of the equation by 2. So that means I cannot do it the way I've written it here. That means I need to divide the whole side of the equation by 2. And you can see that that definitely makes more of a mess than what we started out with. So this just emphasizes that you should always add and subtract before you multiply and divide. So my first opposite operation here is to get rid of the 9 by adding the 9 over to the left-hand side. So my negative 9 and my positive 9 cancel out. That leaves me with 20 on the left and a 2x on the right. Now I can do my opposite operation to get rid of the 2. Now I can divide by it. And you see it's much simpler at this point. So my 2 divided by 2 cancels out, leaving me with x by itself. Hence, I'm down to the last step. And 20 divided by 2 gives me 10. So I have my solution of the problem is 10. That means I am on to step number 3, and I need to check the solution to this problem. So that gives me 11 is equal to 2 times, substituting my number n for my variable of 10 minus 9. And I do not know that this is officially equivalent, so I should have a question mark above it. That's my goal. On the right, 2 times 10 gives me 20, and 20 minus 9 gives me 11. So I do have 11 is equivalent to 11, which means I do have my right answer here. So example 3 was a little bit more complicated than example 1 and 2 because we had more steps involved, but this is definitely not bad compared to some of these examples that we have yet to see. So let us move on to example 4. Negative 8x plus 48 is equal to 3x minus 12. Now, I believe that I have worked through enough of these and given you enough information to solve this on your own. So I suggest that you pause the video and see if you can get the correct answer. Now, there's actually quite a few different ways I can start this exact problem, and I will show you all of the ways that you can go about it, but I'll most likely only work it out one way, just because you don't need to see me working out things multiple different times. Okay, so to simplify both sides of the equation, step number 1 here, I actually cannot do that. I don't have any like variables on the left, and I don't have any like variables on the right. So step number 1 still does not apply. Now I need to use opposite operations to isolate my variable. Notice I have a variable here and a variable there, so I need to put those guys together. And I have a constant term here and a constant term there, so I need to put those guys together. Now this is how you can start this problem in different ways. My tendency is to move my variables to the left, so that means I would move my 3x to the left, and to counteract that, I would move my constants to the right. But that's not the only way I can start this problem, and I'll show you the other way here in a minute. So to move my 3x to the left, my opposite operation would be to subtract 3x, and let me get rid of that underline so it doesn't look like division. So negative 8x minus 3x gives you a negative 11x. And to move my 48 to the right, I would subtract 48 from both sides. Cancels out the 48. And so negative 12 minus 48 gives me negative 60. Now, to isolate my x variable, my opposite operation is to divide by a negative 11. So I'm left with x is equal to positive 60 over 11. If I could reduce that fraction, I would. Notice I canceled out my negatives. But notice I did not change it to a mixed fraction, and I definitely did not change it to a decimal. Improper fractions are always the best format. I know you may have been taught something different back in grade school or since then, but in this class, improper fractions are the easiest numbers to work with. So I have my solution of 60 over 11. Now, I will check that here in a minute, but let me show you the other way to start this problem. Okay, so I have the exact same problem written over here on the right. Now, what I chose to do was to move my variables to the left and my constants to the right. You could have actually chose the opposite way. I could move my variables to the right by adding 8x from both sides. And the advantage to that is then you only have positive variables to be dealing with. And if I did it that way, then I would also move my negative 12 to the left by adding 12 from both sides. So that leaves me with a positive 60 is equivalent to a positive 11x. And of course, the last operation is the same, is to divide by 11. So we would have the exact same solution of 60 over 11. So it does not matter which way you move these things about the equation, as long as you follow legitimate mathematical rules, like those equations of property that we learned earlier. Okay, now I need to prove to you that this works out to be a true equation. So I need to now check my solution. So once again, I have the exact same equation written down here, and I'm going to check it by substituting in 60 over 11. I do want to show you that this does give me the correct solution. So I have negative 8. Instead of x, I'm going to use 60 over 11 plus 48 is equivalent to, or I'm hoping it's equivalent to, 3 times, again, instead of x, 60 over 11 minus 12. So the first thing that I need to do is I need to multiply these here following my PEMDAS rules. Reduce if I could, which I cannot, so I'm just going to multiply straight across, and I can put these over 1 if I need to. So on the top left here, I have negative 480 divided by 11 plus 48 is equivalent to here 180 divided by 11 minus 12. Now I need to add these here by coming up with a common denominator. Well, 48 and 12, I can write them over 1, so my LCD will be 11. So I need to multiply those by 11 over 11. That gives me negative 480 over 11 plus 528 over 11 on the left, and 180 over 11 minus 12 times 11 gives me a 132 over 11 here. Now I just need to put my fractions together, and I just do that by combining the numerator since I have a common denominator. So negative 480 plus 528 gives me a 48 over 11 on the left. And on the right, 180 minus 132 gives me a 48 over 11 on the right. Since I have the exact same things on both sides of the equation here, that means I have the correct solution. So that means 60 over 11 does check out, and I have my official final answer to this problem. Okay, so we worked through example 4. I have one more example for you here. This is example 5. I suggest that you pause the video and see if you can come up with the correct solution to this one. So this is the first problem where step number 1 does apply. I do need to simplify my left-hand side of the equation here before I start rearranging things around this equal sign. So I simplify it by distributing my 2 and my negative over here on the left. That gives me 8x minus 6x plus 10 is equal to 40. So most importantly, don't forget to distribute the negative with the 2. Again, I can simplify more over here on the left by combining like terms. 8x minus 6x gives me 2x plus 10 is equal to 40. I cannot go any farther in my simplification process because I do not have like terms on the same side of my equation. That means I need to start moving things around the equal sign to isolate my variable. My first step to do that is subtract 10 from both sides. Remember, always add and subtract before you multiply and divide. Gives me 2x is equal to 30. And to get rid of my 2, I divide by it. So that gives me x is equal to 15. So I'm down to step number 3, where I need to check this solution. I do that by plugging in 15 for each place that I see an x in my original equation. And when I simplify it, hopefully that simplifies to be 40 on the right. So I have not talked you through the check process here step by step, and I most likely will not do that from here on out because this is a review from things that we've seen already way in the previous part of this semester. So you do see that I have checked it, and you do see that I have equivalent things on both sides of this equation here, which means that my answer is the correct answer over here. So I strongly encourage you to do this step on your own, even though I might not walk you through it step by step here on the videos. So just to recap, the steps to solving linear equations are simplifying both sides of the equation individually. Then we move things about the equal sign by doing opposite operations, addition and subtraction before multiplication division. At that point, you should have isolated your variable. You should have reached your goal. And so you should always check your final answer to confirm that you have the correct answer in the first place. Three times 60 gives me 180 over 11. 180 over 11 minus 132 over 11 gives me 48 over 11. Again, that gives me 180 over 11. 180